Hello everyone, I am Pravin Prakash Baji, student number 1037541. Research topic Social Media Code Mix Text Sentiment Analysis. Today, we embark on the fascinating journey into the world of sentiment analysis in code mixed text. In our increasingly interconnected world, understanding public opinion and sentiment has become a paramount for decision making, trend detection, and effective communication. However, the rise of code mixed text in multilingual social media interaction poses unique challenges for sentiment analysis. Today, we will explore how the data augmentation techniques can bolster sentiment analysis model in the complex linguistic landscape. Before we dive into our research, let's make a moment let's take a moment to survey the existing studies in sentiment analysis and code mixed text. Sentiment analysis has played a pivotal role in interpreting social media sentiments, but code mixing, the coexistence of multiple languages within a single utterance or conversation presents new hurdles. To address these challenges, researchers have explored various data augmentation and model pruning techniques by drawing on, on this vast body research. We lay the groundwork of our innovative approach to sentiment analysis. Let's delve into the challenges that form the crux of our research in sentiment analysis of code mixed text. Each, ex- each challenge presents a unique hurdle that we must overcome to enhance sentiment analysis accuracy in multilingual social media interaction. The first challenge lies in the linguistic diversity of code mixed text. Unique languages blending demands innovative interpretation techniques to decipher sentiments accurately. Standard sentiment analysis model struggles within the intricacies of code mixing, making it imperative for us to devise novel approaches. As we navigate through code mixed text, we encounter the challenges of the contextual understanding. Model must grasp the cultural influences that affect sentiment expression. This require going beyond language and understanding of nuances of a sentiment across different cultural contexts. Scarcity of annotated code mix dataset poses a significant obstacle. The lack of diverse and comprehensive training data hinders the development of a robust sentiment analysis model. Our research aims to address this limitation and create comprehensive datasets for training and evaluation. Model adaptability is a crucial for accurate sentiment analysis in diverse code mixing scenarios. Existing model often struggle to generalize well to the various language blends, limiting their effectiveness in real world application. Our proposed approach aims to enhance model adaptability to and performance. Reasonable AI development is of utmost importance. As we analyze sentiments in code mix text, we must address potential biases that could emerge from the model design and data construction. Our research emphasizes ethical consideration to ensure unbiased and equitable sentiment analysis. Scaling Scaling sentiment analysis to handle large volume of social media data in real time present computational challenges. Our research endeavors to optimize model efficiency, enabling faster and more efficient sentiment analysis on vast social media platform. To tackle such challenges head on, we propose the novel deep learning approach in sentiment analysis. for code mixed text, drawing drawing on a state of the art technique in a multilingual natural language processing. Our approach aims revolutionize sentiment analysis in diverse social media interactions. Our goal our goal are ambitious and focused on transforming sentiment analysis in a code mixed text. We aim to capture nuances, sentiments accurately, ensuring model adaptability to handle complex language blend. Additionally, we strive to overcome data scarcity challenges and optimize computational efficiency for a real world application. Now, let's venture into the data collection process that underpins our research. Our exploration center around the SAIL 2017 dataset, a valuable resource s- specifically curated for a sentiment analysis of code mixed text involving Indian languages mixed with English. This dataset captures the dynamic nature of a social media interactions, allowing us to analyze sentiments across various Indian languages and English. Understanding the data collection process help us to contextualize the diverse social media landscape represented in our research. Let's begin our exploration on data aggregation augmentation techniques with a synonym replacement. This this techniques involves replacing word in the text with their synonym. By introducing synonym variations, we increase the diversity of the training data, enabling the model to generalize better. The impact of synonym replacement was more pronounced for a simpler model like a naive bias, while complex model like a BERT already had a good understanding of a semantic similarity. Next on our list is a translation. This powerful technique involves translation the text to the another language and then translating it back to the original language. The introduction of the introduction of variability in the phrasing without changing the sentiment enriches the training data. Translation had a substantial positive impact, especially on complex model like BRT, and enhancing their ability to learn robust representations. Now, let's explore noise injection. This technique introduces small amount of noise into the data, such as a misspelling or grammatical errors. Noise injection improve the model of robustness to the real world noise data now real world noise data. However, it is introduce the risk of making the model more tolerant to errors, which could be detrimental to certain application. Moving on mix up and integrating the technique that generates new training samples by making linear combination of the feature vectors and labels of two randomly chosen training samples. Mix-up significantly improve model performance by encouraging the model to behave linearly in between training samples, enhancing the model's generalization ability. Last but not least, let's delve into the GAN-based augmentation. This technique harnesses the power of GAN to generate synthetic training samples that resemble the real data. When used combination with the techniques like a back translation or mix-up, GAN-based augmentation showed promising result, further boosting model performance. With the comprehensive understanding of our dataset, let's delve into the core of our study. The experimental setup, our sentiment analysis arsenal comprises the array of models ranging the ranging from traditional algorithms like naive Bayes to state-of-the-art deep learning model like BRT and LSTM. To optimize model efficiency and generalization, we employ data augmentation techniques to enrich our training data. Additionally, we explore model pruning model pruning methods to streamline the model of a real world application. The moment we have been eagerly waiting, the results of our data augmentation techniques. We present we present the impact of the each technique on model performance. Our finding reveals that synonym replacement increases the model diversity, particularly benefiting similar model like naive Bayes. Back translation, on the other hand, significantly improves performance, especially of a complex model like BRT. Noise injection shows a mixed result, enhancing robustness but also risking increased error tolerance. Mixed up and Mixed up encourages linear behavior in between sample boosting generalization. Lastly, GAN-based augmentation yields promising results, especially when combined with other techniques like back translation and mix up. With our results, let's engage the provoking discussion. We delve into the insights gained from the experiments of explore their implications. Our data augmentation and model pruning strategies have strengthened sentiment analysis in code mixed text, highlighted the st- potential for the more okay for potential for the more accurate and contextually aware predictions, addressing challenges such as the linguistic diversity and limited data. Our research contributes to advancing sentiment analysis in multilingual social media. As we approach to the conclusion, our journey, we As we approach to the conclusion of our journey, we arrive at the main takeaways of our research. The successful combination of data augmentation and model pruning significantly enhances sentiment analysis performance in code mixed text. Our work sheds light on the complexities of a sentiment analysis in diverse social media settings, providing valuable insights of a future research and real world application. But our journey doesn't end here. The horizon of sentiment analysis and code mixed text is vast, offering numerous avenues for a future exploration. We suggest exploring multilingual code mixing, further enhancing the contextual understanding and incorporating user interaction to personalized sentiment analysis. Additionally, addressing social biases, optimizing model adaptability, and considering computational efficiency remain promising areas for future research. Thank you. As we conclude this presentation, we want to express our heartfelt thanks to the LJMU and Upgrade for their support and belief in our potential. We are grateful for the opportunity provided and look forward to making meaningful contributions in the world of sentiment analysis and beyond. Thank you.